today we are going to learn about event loop and how we can use and utilize event loop in our LLM generative AI solution code. Okay, so event loop is basically used when we are writing code in asynchronous mode. Like there are two ways to write your code. First one is synchronous and the second one is asynchronous mode. In the synchronous mode, like you have multiple tasks. So in the synchronous mode, the first task uh, the second task would start when the first task was finished. So it completely sequential manner, your task executed in the synchronous. But if you are writing code in the asynchronous mode, then then it not dependent on the first task to start the second task. If your cp utilization idle, then it would start the next task. Like if you have two tasks and the first task is waiting for some input from the user, so meanwhile the second task would execute. So event loop is the event loop in Python is the core mechanism that allows asynchronous code to run efficiently. Okay, so what it does, like it waits for the task like network request, file reads and timers, and then once the task are in the ready state, then executes them. uh, then executes them. Okay, and it has the capability to switches between tasks without blocking the whole program. So event loop does all those things. Okay, so let's see how we can utilize the event loop, and where it is, where we can use the event loop. Like I have written a function, so all those things we can do using the asyncio library. So asyncio dot run say hello, so it would create a, new event loop. But we are doing some code in the Jupyter notebook. It means a event loop already running, and running by the Jupyter notebook. So I can't create a another event loop in the running event loop. So that's why I use the await and say hello. So I have written this function. So if I add a sync, it means this is a coroutine function. So once you print, like let me print this function, then print say hello. So it is returning a coroutine object. It means when I use the await keyword, uh, then it'll return the final output or run the whole function. So so this is the things. And in the asyncio, I have calling this function, and this function delays of 1. So let me run this function. So hello and world. So after 1 second it printed world. Okay, so this is a task. This is a one task, and it is executing the one task in the event loop. Like event loop create a stack and whenever a task is ready to execute, then put that task into the stack. And if the running task is waiting for any input from the user, then it removes that task from the stack and put the other task whichever is in the ready state. Okay, so let's see how event loop handles the multiple tasks. Like like this is a function, this returns the coroutine objects and asyncio.gather. Asyncio.gather, so we are creating a stack and we are putting three tasks together in that stack, and task a takes 2 seconds to execute, task B takes 1 second, task C takes 3 seconds. It means these are the delays in the task. So okay, so when task A executing and waiting 2 second, meanwhile the task B executed, and then task C. So so in 3 second, three tasks will execute. So let's check. Okay, and the next is the simulating an async LLM call. So in this I have created a dummy fake call for LLM, and it takes it, and I have added 2 seconds of delay in the function. So and this is the async function, and I'm getting the response using the await keyword. So that's how you can use the event loop. And some of the event loop things I want to to tell you. So in the at the end of the experiment section, you have the calling. You can experiment with calling multiple LLM prompts, and which takes a lot of time. So because if you are trying on the multiple LLM calls, so it means if a one call takes 4 seconds of time, and the another call takes only 2 seconds of time, then the maximum 4 seconds of time would take of the whole execution. So that is the whole idea behind the event loop. Okay, thank you.